Assalamualaikum and good day to everyone. How are you doing? I hope everything is going well with you and your family. Okay, today we will discuss about the entity relationship modeling. In this lesson, we will take a look at entity and also the relationship. For your information, these topics are divided into three parts. For part 1, we will focus on entity type and relationship types. For part 2, we will learn more about entity types and attributes. And for part 3, we will focus on structural constraints or multiplicity. Let's look at the learning objective of this topic. Okay, you guys should be able to define basic concepts associated with ER diagram and produce or construct ER model to represent information to application system. We will go further on the ER modeling. ERM is existed as to explore the different ways that entities can relate to each other as they always do in the real world. ER modeling is a top-down approach to database design that begins by identifying the important data called entities and relationships between the data that must be represented in the model. We then add more details such as the information we want to hold about the entities and relationships called attributes and any constraints on the entities, relationships, and attributes. The ER diagram shown in this slide is an example of one of the possible end products of ER modeling. This model represents the relationships between data described in the requirement specification for the branch view of the DreamHome case study. Okay, as you can see here, there are a number of different notation that can be used for modeling ER. We have chosen a diagrammatic notation that uses an object-oriented modeling language called Unified Modeling Language or UML. Although we use the UML notation for drawing ER models, we continue to describe the concepts of ER models using traditional database terminology. Okay, move on to the next slide. Okay, next is the concepts of the ER model. For your information, the things that you need to know in order to construct the DER model are entity, relationship, and the attributes. The basic concept of the ER model is the entity type, which represents a group of things or objects in our environment that we want to keep track of. For example, in university environment, we want to keep track of students. Entity types is a group of objects with the same properties which are identified by the enterprise as having an independent existence. Entity occurrence or instances is a uniquely identifiable object of an entity type. We identify each entity type by a name and a list of properties. A database normally contains many different entity types. Examples of entity types are student, subject, and lecturer. Okay, next is about entity representation in diagram. This is how actually we draw the entity in our diagram. Each entity type is shown as a rectangle or box labeled with the name of the entity, which is normally a singular noun. In UML, the first letter of each word in the entity name is uppercase. Attributes are listed inside the box, and you must have a primary key for each entity. Okay, now we move on to relationship. Relationship type is a set of meaningful associations among entity types. Each relationship type is given a name that describes its function. Express how entities are mutually related and always exist between two entities or one entity twice. Relationship occurrence is a uniquely identifiable association which includes one occurrence from each participating entity type. This is the example of semantic net view of the relationship. Consider a relationship type called has, which represents an association between branch and staff entities, that is, branch has staff. Each occurrence of the has relationship associates one branch entity occurrence with one staff entity occurrence. The semantic net in this slide shows three examples of the has relationship denoted R1, R2, and R3. Each relationship describes an association of a single branch entity occurrence with a single staff entity occurrence. Relationships are represented by lines that join each participating branch entity with the associated staff entity. For example, relationship R1 represents the association between branch entity B003 and staff entity SG37. So we represent each branch and staff entity occurrences using values for the primary key attributes, namely branch number and staff number. And this is a diagrammatic view of the relationship. Each relationship type is shown as a line connecting the associated entity types. And each relationship must have a name. Normally, a relationship is named using a verb or a short phrase including a verb. A relationship is only labeled in one direction. That means the name of the relationship only makes sense in one direction. For example, branch has staff makes more sense than staff has branch. So, once the relationship name is chosen, an arrow symbol is placed beside the name to indicate the correct direction to interpret the relationship name, as shown in this slide. Let's take a look on degree of relationship. It is defined as the number of participating entities in a relationship, which indicates the number of entity types involved in a relationship. A relationship of degree 2 is called binary. A relationship of degree 3 is called ternary, and a relationship of degree 4 is called quaternary. The figure shows the example of binary relationship. Binary relationship means two different entities are connected to one relationship. An example of a binary relationship here is the POwns relationship with two participating entity types, namely private owner and property for rent. The term complex relationship is used to describe relationship with degrees higher than binary. The UML notation uses a diamond to represent relationships with degrees higher than binary. The name of the relationship is displayed inside the diamond. For ternary relationship, we have three different entities connected to one relationship. An example of ternary relationship is registers with three participating entity types, staff, branch, and client. This relationship represents the registration of a client by a member of staff at a branch. And for quaternary relationship, we have four different entities connected to one relationship. So in this example, a quaternary relationship called arranges with four participating entity types, which are buyer, solicitor, financial institution, and bid. So this relationship represents the situation where a buyer advised by a solicitor and supported by a financial institution places a bid. So next, we talk about recursive relationship. Recursive relationship is a relationship type where same entity type participates more than once in different roles. Relationship may be given role names to indicate purpose that each participating entity type plays in a relationship. Recursive relationships are sometimes called unary relationships. Rule names can be important for recursive relationships to determine the function of each participation. If we take a look at the example of recursive relationship called supervises with role name supervisor and supervisee here. The staff entity type participates twice in the supervisor's relationship. The first participation as a supervisor and second participation as a member of staff who is supervised. Okay, next is about entities associated through two distinct relationships with role names. Role names may be used when two entities are associated through two distinct relationships. This slide shows an example of entities associated through two distinct relationships called manage and has with role names. The use of role names clarifies the purpose of each relationship. For example, in the case of staff manage branch, a member of staff in staff entity, given the role name managers, manage a branch in branch entity, given the role name branch office. Similarly, for branch has staff, a branch given the role name branch office has staff given the role name member of staff. I guess that's all for now, and see you again in next part. Thank you.